Yes, this is the question. Question is, a student finds that there are 20 divisions between 0 mark and 1 volt mark of the voltmeter. एक वोल्टमीटर है, उसके 0 और 1 वोल्ट जहां लिखा हुआ है, दिस इज 0 मार्क, दिस इज 1 वोल्ट मार्क. There are 20 divisions between 0 and 1. The question is that what is the least count of the voltmeter? What is the least count? As you know, the exact smallest value then can be read from the voltmeter. So if there are 20 divisions, the value of 20 small divisions, वैल्यू है 1 वोल्ट. 1 स्मॉल डिवीजन की वैल्यू 1/20. So this will be 0.0 here 0 1 0 more 5 0.05. LC जिसे निकालते हैं LC 1 वोल्ट 1 वोल्ट में स्मॉल डिवीजन से 20, 1 divided by 20. This will be the least count. 0.05 volt. These are very smart questions. Now, one next very interesting question is, we are taking some questions on Ohm's law. So there are two circuits. Question 3. Two circuits are there. See carefully. Four cells have been connected. This is plus, this is minus, this is emitter. Now here is the resistance R. A voltage, a voltmeter is put here. V. The voltmeter. Now this is the key J. In second case, this is a meter, this is the resistance R, a voltmeter V is put here. This key and this goes to here. There are 4 points. This is one A, this is B, this point is C, and this is D. This point is D, this is A, and this is J. here the point is A here. This is A. The second one is B. It is C, and this is D. This point is D. This is C. This is B. This is A. Let us use the different color. This is A, this is B, this is C, and this is D. Similarly, here is point A, here is B, here is C, here is D. This is the rheostat. These are cells. They are plus, minus, then again plus, this is minus, this is plus, this is minus, this is plus, this is minus. The question is, here is the key, switch. Now see the circuit carefully. Contact point is J. इस J पॉइंट को हम कहाँ टच कराएं? A, B, C, D पर. ऐसे यहाँ पर. In the similar way, where the J should go, where the J should make contact at A, B, C, or D, such that ammeter and voltmeter readings will be maximum. Find the position of J in figure A or in figure B. Find the position of J. J should be at A or B or C or D. Similarly here in A, J may be at A or B, C or D. You have to find out the position in both the figures, that readings of ammeter, this, and voltmeter, this, are maximum. Question is reading of ammeter and voltmeter should be maximum. You have to find out the position of J. So in question, there are 4 options. One is D. D in the both sets up. D in the both setup. Let us analyze. Let the J comes on D, and here also J is connected at D. So what happens here? J is connected at D. Then in this circuit, the voltage will be maximum. All the cell will come in the circuit, so the voltage will be maximum. But what about the current? Let this be the current. When the voltage will be maximum, so R is fixed. So according to the Ohm's law, the current will also be maximum. So here the position D in figure A, position D is okay. If we take a position D here, so what happens? This rheostat, the total resistance of rheostat will come into the circuit, and here the voltage is fixed. So this will come into the circuit. The maximum drop of voltage will also take place here. So across the resistance, the voltage drop will be the voltage drop of this much voltage the V, this is V maximum, सभी सेल का मिला के V maximum है, तो this will divide into this rheostat and this resistance. तो वैल्यू ऑफ V, इस वोल्टमीटर की वैल्यू मैक्सिमम नहीं होगी D पे कनेक्ट करने पर. तो where the next option is A in both the sets up. It is not possible. We have found out at D in figure A the value of current and voltage will be maximum. We have to find out in this circuit where J should go so that we get the maximum value of A and B current. So naturally you connect here, J will come here, it will connected here. Then what happens? There is no extra resistance. There is no part of rheostat coming into the circuit. The circuit will start from here. I will start from here. Will go here. You will close this. It will go here and this will be circuit. So when the position of J is at A, then the value of voltage as well as current will be maximum. So in figure A, the position of J will be D. Any answer will be position of J should be at D in figure, in circuit, in CKT circuit A and at point A in circuit B. See carefully. It is very interesting, very important question. If I analyze when J is at A, there is no this resistance. Let put the J here at B, connect at B and analyze this circuit. What happens? Total resistance in the circuit will be this resistance which also come into the circuit. So this voltage V will be divided across this. Let I be the current. Let I is the current in this circuit. So this is, let this part of the rheostat has the resistance R. So what happens? This maximum जो voltage है V max, जो voltage applied है maximum voltage circuit में है. अब this will be divided into I into R plus I into R. So this IR will be shown here. So the value of reading this V will be less than this one. मैक्सिमम से कम रहेगा. तो इस केस में हम और इसको और इधर बढ़ा दें, D पे कर दें, तो ढेर सारा रेजिस्टेंस है, पूरा का पूरा रेजिस्टेंस आ जाएगा. तो लो A and 2 3 पार्ट में रेजिस्टेंस है, तो लेट इट बी, इट विल कम I into 3R and plus IR. Here the current will be someone else, I dash. So this part will increase and this will decrease. So the value of reading of voltage will again go down, and that will be the position of minimum voltage when the J is connected at D. So the required position of J in this figure is A, because we don't want any extra resistance in the circuit. So voltmeter here gives maximum reading. Let us take up next question. Very small question. In the circuit given below, The instrument B reads 0.93 and instrument A reads 1.8 in their respective SI unit. Let us make the circuit first. This is your circuit. This is rheostat, and here is connected called instrument B, and here is a resistance R, and an instrument here connected is called A. He is saying there are two instruments connected in this circuit, instrument A and instrument B. The reading of B, इसकी रीडिंग है, यूनिट नहीं बता रहा है, तो क्या यूनिट है आप जाने, 0.93, 0.93, and the value, the reading of this is 1.80. दोनों का SI यूनिट में रीडिंग है. रीडिंग इज गिवन इन SI यूनिट in case system. So you know in the circuit that if this is the resistance, so what this instrument is, the instrument A. For your confusion, it is written that this is instrument A. You may confuse it for ampere, ammeter, but this is not ammeter. It is connected in the parallel to the resistance. So what is this? Instrument A is voltmeter. Instrument A क्या है? Voltmeter. Voltmeter, and this is connected in series. This is plus, this is minus. This is plus, this is minus, this is plus. So this is voltmeter and this is ammeter. Instrument B is ammeter. Now the what is this value? This is ammeter, this is ampere, and this is voltmeter connected in parallel to R. This is connected in series. So this is voltmeter B. So now apply Ohm's law. पूछ क्या रहा है? The value of unknown resistor, the value of R. So V is equal to IR. We know by Ohm's law. R is equal to, very simple, what to calculate. This is pure mathematics. And 1.80 divided by 0.93. Approximately 2, just less than 2. The four figures are given: 0.51 ohm, 1.63 ohm, 1.93 ohms, 19.3 ohms, 1.93 ohms. Naturally, if 0.93 के बजाय 0.90 होता तो ये 2 ohm हो जाता, and your nearest value is given 1.93 ohm. So this is the right answer. Okay. Be attentive, be careful. Now very small questions. The scale of ammeter is shown below. जगह है लिखता हूँ. This is the scale of ammeter. This is 0. Here is 1. Here is 2. And given here is 3. This is ammeter का scale है. Scale of ammeter is given here. The least count of this ammeter. One thing more. Each here are between 0 and 1, here are 10 divisions. Similarly, between 1 and 2, 10 divisions. 2 and 3, small 10 divisions. So you know the least count. The minimum reading then can be taken exactly is the least count. Or you can say the value of one smallest division of the scale is called least count. Choti se choti least. 1 ampere, 10 division, 1 ampere divided by 10. So one small division की value 0.1 ampere. This is the least count. Similarly, a very small question next. वोल्टमीटर का स्केल दिया हुआ है, गिवन है स्केल ऑफ वोल्टमीटर, डायल ऑफ वोल्टमीटर. वोल्टमीटर दिया हुआ है. Let me consider it become the voltmeter. Now this has become the dial of voltmeter, and there are 5 divisions between 0 and 1 mark. This voltmeter, this is the scale of voltmeter, and this is 1 volt here, 2 volt here, 3 volt here. 0 mark is here, and there are 5 small divisions between 0 and 1. Similarly, between 1 and 2, there are 5 divisions and so on. So least count, least count LC, value of one small division. So 1 volt, here is 1 volt, 1 volt, and divided by number of small divisions 5. 0.2 and 0.2 volt. If the needle is here at 1, okay. If the needle is here, this division, first small division, so what is the value? 0.2 plus 0.2 plus 0.2 plus 0.2 plus 0.2 plus 0.2. Any 0.2 multiplied by 5, so 1. So one small division की value 0.2 volt. This is the least count. Let us take some very good questions. Very interesting. There are 4 circuits given. Okay. Let us make 4 circuits. This is battery, this is voltmeter. Now other circuit, the battery, same battery, here is the meter, here is, this is, I have connected a voltmeter here. Connected the voltmeter here. Another circuit is here is connected the voltmeter. Another circuit is connected ampere meter, same circuit. Here is connected, and here is connected voltmeter. Read carefully, see carefully the circuits. This is plus, this is minus, this is minus. The question is on plugging the key. This is the key. Plug the key and close the circuit. On plugging the key, the voltmeter or ammeter is likely to be damaged. किस सर्किट में डैमेज होगा? Now let us analyze. If we plug this circuit, the voltmeter is in series. The voltmeter, you know, the voltmeter has a very high resistance, so very less current will flow. So this voltmeter will not damage. Now take this voltmeter, again is in the series, so current will be restricted in the circuit, very less current will flow. So neither voltmeter will damage nor ammeter will damage. Now these are the same circuit. So here also ammeter and voltmeter are in. This is given the same way. The ammeter and voltmeter are given in the circuit. If you plug the key, if you close the circuit, what happens? A current will flow, but though the ammeter has very less internal resistance, voltmeter has very high internal resistance, the current in the circuit will be very low. Current will be very low. So this will also not damage, neither A will damage nor. Here what happens here? The internal resistance of the meter is very low. You know it is. The meter is made in this way that internal resistance is very low. And there is no resistance in the circuit, no other resistance in the circuit. Here a big resistance in the form of voltmeter in circuit. In this circuit a big resistance, this has a big resistance in the circuit. So this is a big resistance in the circuit. This circuit has also a big resistance, and this circuit has also a big resistance. So the current is limited in these three circuits. So what happens here? There is no resistance in the circuit at all. And if you assume ideal circuit, the R is R is less than, R is just equal to 0. So what will be the current? Current will be very high, any infinity. So here this ammeter will damage. Let the internal resistance will be very small, so current will be, R is very small. In this circuit, the resistance is this very small internal resistance, R. But the current will be very high. So this circuit, in this circuit, the ammeter will be damaged. क्वेश्चन यही पूछ रहा था कि ये चारों सर्किट में, सर्किट क्लोज करने पर या की प्लग करने पर किस सर्किट में अमीटर जल जाएगा या वोल्टमीटर जल जाएगा. Now the next question is, थोड़ा सा दिमाग लगाने वाला है. It is very good question. The rest positions of needles in milliammeter and voltmeter when not being used in circuit are as shown in the figure. The zero error and least count are these instruments are put apart out of circuit. तो ये डायल है, डायल में बना रहा हूँ, मिटा दो इसे. ओके. This is the dial of milliampere. अमीटर है जिसका डायल मिलीएम्पियर में है. This is 0 and this is 10 and this is 20. This is MA, milliampere, dial of milliampere. And this 0 to 1, S0 to 10 milliampere. This 0 to 10 milliamperes is divided in 5 parts. So, एक दो तीन थोड़ा बड़ा कर दो. 1 2 3 4 5 5 part में. Similarly here 5 equal divisions, 5 equal spans, 5 equal part में 0 से 2. ये मार्क जो है डिवाइडेड है इसके लिए. Now the needle is here. The needle is here. These instruments kept apart, not connected to the circuit. And another, let me find one by one. Another is a voltmeter. वोल्टमीटर का 0 यहाँ है. This is 0 and this is 1. Similarly here is 2, here is 3. This is voltmeter V. This dial is a voltmeter. This 0 to 1 is divided in 10 parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The needle is here. इस पे है. See carefully. The question is, the zero error and least count of two instruments. Let me take this one first. Ammeter. So this is left side of the 0. What happens? This is on the negative side. So how much is on the negative side? 2 divisions. So यहाँ 10 milliampere is divided in 5 equal divisions. So 1 division की value, the value of 1 division, any LC is equal to 10 milliampere is divided by 5. Any it is 1 division equal to 2 milliampere. This is the least count of this. Now, what is the zero error? Take it carefully. सपोज इसको सर्किट से जोड़ते हैं, अब मेजर करते हैं सर्किट में, करंट का मेजरमेंट करते हैं। अब लेट इट बी 10, it reaches here, needle is reaches here 10 milliampere। सर्किट में डालने पर ये 10 में आया, तो वास्तव में ये जीरो से, दिस नीडल जीरो से स्टार्ट करके 10 पे नहीं पहुंचा। दिस नीडल वाज बिफोर जीरो and 2 divisions before zero, and it has reached at the mark 10. If you don't know the instrument, don't check the instrument before connecting, and after making the circuit, closing the circuit, you will take the reading. The reading will be 10 milliampere. But what is the actual reading? This has moved from here. तो दो डिवीजन इसमें जुड़े हुए हैं। Actually, if it would have been here at zero, माने instrument has no least count, then this reading will be somewhere here at 2 divisions, यहाँ पे तो 12 पे होता। तो इसमें जीरो एरर क्या है? What is the zero error? Zero error, if it is here, the needle was here, and the system is not connected, the needle was here. So zero error, 2 divisions, 1 division 2 milliampere, need 4 milliampere, 2 milliampere, 2 milliampere, 4 milliampere, 4 milliampere, but it is in the negative side, so it will be taken with its साइन। नेगेटिव साइड में है, लेस है, तो बाद में इसको एलसी में प्लस करते हैं एक्चुअल रीडिंग में, तो दिस विल बी -4 मिलीएम्पियर। तो एक्चुअल रीडिंग, इफ योर नीडिंग योर रीडिंग इज 10 मिलीएम्पियर, तो एक्चुअल रीडिंग, एक्चुअल वैल्यू इज इक्वल टू